Hello everyone, welcome back to my channel. I'm Engineer Kim, a registered mechanical engineer and a freelance designer. Today we're starting a new project, the Pneumatic Scissor Lift. In this part 1, we'll focus on the main components, the base frame, linkages, and the pneumatic cylinder. We'll talk about their descriptions, functions, and the key factors to consider when designing a scissor lift. Also, sa part 2, we will do the full assembly of all the components and even animate the lift motion. So you'll see exactly how it works in action. So tara, let's start. So let's start with the base frame. Ito yung pinaka-foundation ng scissor lift. Parang foundation ng building. Usually gawa siya sa steel square tubes or heavy duty channels. Kasi kailangan nitong suportahan lahat ng weight. Yung platform, yung load at pati forces galing sa linkages at cylinder. So may iba't ibang design tayo ng base frame. Some are simple rectangular frames while others have reinforcement like cross beams or gussets para mas stable. Rectangular frames are simpler to build pero may chance na ma-flex under load. Reinforced frames are stronger pero heavier at more expensive. So ang function ng base frames to provide stability and support. All other parts attached to it. Kung mahina ang entire system, may bend, warp, or even collapse. Kaya material selection, thickness, and welding quality are very important. Also, make sure corners are squared and aligned. Even small misalignment creates stress points that can lead to failure. So ano nga ba mga factors to consider? First is the material strength. Usually, mild steel, stainless steel, or aluminum depende sa application and budget. And for the dimension naman, mas malapad at mas makapal, more stability pero heavier and costly. For the mounting points, holes and brackets must be precise and aligned. And for the surface protection, painting, powder coating, or galvanizing to prevent rust, especially if outdoor use. So, tip ko lang is if you are lifting a 500 kg, always calculate the frame's load capacity and add a safety factor of at least 1.5 to 2. This ensures safety and durability. The next part is the linkages. These are the X-shaped arms that create the scissor mechanism. Usually, dalawang pairs or more, depende sa desired lift height. They're typically made of steel flat bars or rectangular hollow sections, strong enough to handle load pero not too heavy. Linkages convert linear motions from the pneumatic cylinder into vertical motion. While the cylinder pushes, the linkages transfer that motion to lift the platform evenly. They also help distribute the load across the system. Kapag hindi pantay ang linkages, may risk na uneven lifting or bending ng arms. So we have a factors to consider. First is the geometry and length. So longer arms, mas higher yung lift pero slower yung movement. Cross-section or yung thickness, prevent buckling under compression. Pin joints and bearings. So durable at low friction para smooth ang motion. Alignment, ito yung pinaka-critical para hindi ma-jam ang mechanism. And then is the lubrication. Regular maintenance para smooth ang operation. In summary, linkages is the heart of the lift, converts cylinder motion to vertical lift and distribute load evenly. And for the last part naman, we have the pneumatic cylinder. This is the muscle of the scissor lift. It uses compressed air to push and pull the piston rod. Usually, double-acting cylinders ang gamit para controlled ang lifting at lowering. The cylinder must be sized properly. Too small is underpowered. Too big naman is inefficient and costly. So the right cylinders ensure smooth and reliable lifting. So ano nga bang function nito? It provides actuation force. Compared to manual or hydraulic system, pneumatic cylinders are cleaner, faster, at low maintenance. Pero kailangan reliable ang air source for consistent performance. So ano nga ba yung mga factors to consider? First is the bore size. It determines the lifting capacity. Bigger bore is more force. And for the stroke length, it determines maximum lifting height. Then for the operating pressure, should match the compressor. So usually 6 to 10 bar ang kanyang pressure. And then for the mounting style naman, we have flange, clevis. So depende sa design. And for the rod strength, prevents bending under heavy loads. And last is the seals and cushioning. It prevents leaks and ensures smooth motion. And tip ko lang sa inyo, always calculate the required force based on your load and linkage ratio. For example, if you want to lift 300 kilograms, calculate the air pressure needed with your cylinder bore and stroke. Then add a safety factor. So usually, ang safety factor is 1.5 to 2. Regular maintenance of seals and rods is key. Check for air leaks and lubricate moving parts to ensure efficiency and safety. So for a real-life example, if you're using your lift in a workshop, consider frequency of operation. Daily use requires high-quality cylinders and stronger linkages. Occasional use allows some flexibility in material choices. So before we end this video, let's talk about first the description and function of the pneumatic scissor lift. Okay? Pneumatic scissor lift is a mechanical system that allows a platform to move vertically using scissor linkages powered by a pneumatic cylinder, all mounted on a solid base frame. Functionally, it lifts loads safely and efficiently while keeping the system clean, fast, and relatively low maintenance compared to manual or hydraulic alternatives. Okay, that's it for part 1 of our pneumatic scissor lift series. Today, we covered the 3 main parts, the base frame, linkages, and the pneumatic cylinder. In part 2, we will do the full assembly of all the components and even animate the motion so you can exactly see how it works in action. This is the part of our pneumatic scissor lift project. In part 1, we explained the design and components, the base frame, linkages, and the pneumatic cylinder. Today, we're moving on to the final assembly and testing. By the end of this video, you'll see how everything works together as one complete system. So let's start. First, let's prepare the base frame. This is the foundation of the entire scissor lift, so stability and alignment are very important. I'll place the base frame onto the workspace and check if the mounting holes align correctly. Remember, any error here will affect the movement later. Kung mapapansin nyo, I've reinforced the corners to avoid wobbling when load is applied. Once the base is secure, we can proceed to the scissor linkages. Now, let's install the scissor linkages. These are the parts responsible for the vertical motion of the lift. We'll start by attaching the lower linkages with the 5-bolt pins and then align the upper linkages to form the crisscross pattern. So tip ko lang, don't over-tighten the 5 bolts. They should move freely but not too loose. I'm also using washer and lock nuts for added durability. Dito nyo makikita na unti-unti nang nabubuo ang scissor mechanism. So once both sides are aligned and secure, we can move onto the pneumatic cylinder. Now, let's move to the most important component, the pneumatic cylinder. This provides the lifting force of the scissor lift. First, I'll mount the base end of the cylinder to the bracket on the frame. Secure it with a pin, test the extension manually. Next, I'll connect the piston rod end to the scissor linkages. Positioning here is crucial since it defines the stroke length and maximum height of the lift. After installation, I'll check the clearance to ensure there's no interference during movement. Then, I'll connect the pneumatic hose and fittings to the cylinder. Make sure the connections are leak-free kasi kapag may air leak, bababa ang efficiency ng system. Always tighten your fittings properly. At this point, our lift is almost complete. Now, it's time to attach the top platform where the load will be placed. I'll carefully align it on top of the scissor linkages and once the mounting points match, we'll bolt it securely. Naglagay din ako ng mga stoppers sa sides para hindi mag-shift ang platform during operation. With that, the physical assembly is complete. Now comes the testing phase. I slowly apply air pressure to the cylinder. As you can see, the scissor mechanism extends upward smoothly. When I release the pressure, the lip reacts or retracts back to its base position. Well, repeat this several times to confirm the stability and consistency of the motion. Ayun, kita nyo na gumagana ng ating pneumatic scissor lift. So, what is the main function of this pneumatic scissor lift? Basically, it's designed to raise and lower loads with the help of compressed air. You'll see applications in workshops, production lines, and even automotive services shops for lifting vehicles or equipment. Madali lang ang principle, a stable base, strong linkages, and a reliable pneumatic cylinder all working together. And that completes our pneumatic scissor lift project. From design and explanation in part 1, up to the final assembly and testing in part 2. I hope you learned something valuable from this build. If you like this video, please don't forget to follow, like, and subscribe. And comment down below if you have any questions or suggestions for future projects. Once again, I'm Engineer Kim. Thank you for watching and God bless everyone. See you on my next vlog. Bye-bye!